should make this more complicated because one of the homework is more complicated and people are freaking out about it. This might make it be fraction answers, but you're just going to have to deal with it. So what if I said 4a plus b equals 8? Just so you know, I've probably just officially made this a terrible problem, but I'm going with it, okay? Because if it was just 4a equals 8, that's amazing, right? Because you could solve for a right away. But the one on your homework looks more like this. What makes this easier than the other ones is that each equation only has 2 variables. But really frustrating, no 2 equations have the same 2 variables. With me on that? Like, if this had an a and a b and this had an a and a b, we could just do elimination and we could solve it like we've always done it. But because this one has an a and a b, this one has an a and a c, this one has a b and a c, you got to think a little bit of what could I do so I could get to a point that I could solve these equations. I can't solve an equation for a letter unless I get it down to 1 letter. So that's kind of the goal here. So one option would be, could I solve this equation for either a or b and then do like substitution into the other one? That's what I would do. Some people last hour were still doing like elimination, but like the b and c didn't eliminate because they were in there. But for me, this is a substitution problem. So if I solve this for b, do you agree that b would equal 4a plus 8? And how does that help me? Well, because in this equation, I should have solved for a, but that's okay. In this equation, there's a b. So could I replace b with 4a plus 8? And I would get 7 times 4a plus 8 plus 3c equals 22. Just so you know, my board is still not cooperating, so be prepared. So I have to do some work here again. I probably made this really terrible. So I get 28a plus 56 plus 3c equals 22. And I want to make it look like this. I want a, c, and a number. So I'm just going to subtract 56 over here. And I'm going to get 28a plus 3c equals negative 34. Is that true? So what I've done, I did substitution, and now look what I have. I have an equation with a and c in it. I have another equation with a and c in it. That's what we've been doing. This whole chapter is solving 2 equations in 2 variables. So now I can say 5a plus 2c equals 0. And do I know how to solve that equation? Hopefully. I would not do substitution here. I would do elimination. And again, I made this up, so it's going to be awful numbers. But this is where everyone's paper is different, and this is where it takes me so long to grade these problems because there's so many different ways that you could go here. And when you get to the next one, there's even more. But I'm going to make my c's the same because I don't want to multiply by 28. So I'm going to multiply the top one by 2, and I'm going to multiply the bottom equation by 3. This is like the video. Oh, that's an A. I mean, nope, that's a C. Equals negative 68. And then I get 15a plus 6c equals 0. Would I add or subtract here? If they're the same sign we're trying to cross out, we're going to subtract. So what is that? 41a, this cancels out, equals 68. Then I'm going to divide by 41. And I'm going to say a equals 68 over 41. It's negative, thank you. Negative 68 over 41. Now, we're not going to continue this because it's really gross. I mean, we can if you really want. But now it's just a bunch of back substitution. Once you find a, could I go back to the equations that just have a in it Honestly, I could go back to this equation and solve for b right away. And then I could go back to any other equation that has a or b in it, and I could solve for c by plugging it in there. So just know the very first problem on your homework looks like this, only not as ugly because it's not fractions. But you just have to do some substitution first because you have to have two equations with two variables. So it's a little bit different than the one on the video. It's actually a little bit less work. I just made it ugly numbers by just making up a number. So, okay, moving on. We're just not going to solve that over. This one is like the one that was on the video. If you have three equations and three variables, someone asked, why couldn't you just solve it right away? Like, why couldn't you just do elimination once and solve it? When you do elimination, you only eliminate one letter at a time. And you can't solve it until you get down to one letter. So that's why the very first step, and the first thing that he did in the video yesterday, is you have to do elimination 2 times to get down to 2 equations and 2 variables. And then again, this is where my answer key really helps none, because everyone could choose a different letter to get rid of. My advice is, step 1, figure out which letter you're going to eliminate. Hopefully there's one that looks easier to get rid of. Like thinking about elimination and making them the same number. Does X look easier, Y look easier, or Z look easier to get rid of? I would pick Z because these two already have the same number in front of them. And the middle one, all I have to do is multiply by 2. And so again, that's step 1. You could still get the same answer if you pick Y or X. Your work's just going to be different. So I'm going to pick Z, and it doesn't matter which 2 you work with at first, but I'm going to pick the top one and the bottom one because they both have the same number already. I'm going to have to use all 3 at some point, so it doesn't matter which one you use. I always like to mark which ones I'm using because you have to go back and use that third one at some point. So all I'm going to do is rewrite them right here. 5x plus 3y plus 2z equals 2. And x plus 4y plus 2z equals 16. And again, what is frustrating is you make one mistake. You make one negative sign mistake, or you add wrong one time, especially in your first step, everything else is going to be wrong after that because they all depend on what happens throughout the whole problem. So 1, be really careful. Try to watch your negative signs and just try to take your time doing it. And 2, make sure you show your work, because even if it's the wrong answer, I can go back and say, well, they had the right process, they just messed up here, and then that messed up everything else. So make sure that you're not just a hot mess of your work, because I can't read that. The other thing is be really careful on adding or subtracting. When they're the same sign, we're going to subtract. So I have to subtract everything. And so for me, I actually go through and I put my negative sign through on everything, because otherwise I forget it. So that's how I do it. So 5x minus 1x is 4x. 3y minus 4y is minus y. And 2z minus 2z cancels out. 2 minus 16 is negative 14. Notice that normally when we do this, we're down to like x equals some number and we can solve for it. But on this one, we still have 2 letters left because all we did was eliminate z. And that's why step 1 is you have to do this twice. So you have to use elimination to drop out 1 letter 2 different times. So you have to go back and use the equation that you didn't use yet. So I have to use this middle equation, but it doesn't matter if you use the top or the bottom one with it. It doesn't matter. You'll get the same answer because it's all the same system. So again, it's your choice. In this case, it doesn't matter because they both have a 2 in front of it, right? So you just have to pick one. So I'm just going to pick that I'm going to do these 2. But I want the z to eliminate. So I have to make sure I multiply so that these will be the same. So in this case, since this one's already a 2, are you okay if I just multiply that by 2? And I like to just keep it so I can add if I can. So I'm going to multiply by positive 2. But if you want to multiply by negative 2 and subtract, again, we'll get the same answer.
So why do we have that one equation, 4x minus y equals negative 14? When's that going to come into play?
After we do this again. Because we're trying to get to the point that we've always had. If we could have 2 equations and just 2 letters, we know how to solve that. So we can't do anything with this by itself right now until we have another one.
So if we're doing the same thing we just did, use the other equation.
Yes. explaining.
So why do we multiply by 2?
Because I want to drop out the same letter I dropped out already. So since there's a 2 in front of this Z, I'm multiplying by 2 to make them the same. If there was a 4 in front of Z, I'd multiply by 4. So, Angelina, I think your question is going to get answered in a minute after we do this, all right? So, I have 5x plus 3y plus 2z equals 2. And then I'm going to multiply that middle equation by 2. So I have 4x plus 2y minus 2z equals 10. And on this one, since my signs are different already, 2 minus 2 already cancels out. So I'm not subtracting here, I'm adding. So I get 9x plus 5y, the z's cancel out, and I get 12. So what I should have now, why I had to do this first step, is now I have 2 equations that should have the same letter. So I have an equation with xy, I have an equation with xy. So I dropped z out 2 times. Now, Angelina, can we go back and use these 2 equations and do what we've been doing this whole chapter? So now I can do elimination or substitution again and make the x's or the y's drop out. And solve that. And then plug it back in. And then plug that back in.
But we know which equation to put on top. Which one to put first, which one to put second, or does it matter?
Does not matter. Which again is why it's so not fun grading these. Because there's probably about 20 different ways to do this first step here, depending on which letter you're dropping out, which one you put on top, which one you choose to do first. So you just have to make sure that you keep your signs lined up, and it should work. So now step 2 is take these 2 equations that you have that are now in 2 letters and solve them. And so I'm going to rewrite them. You don't have to. You can just figure it out from here. But I'm just going to write them underneath each other since it's our big example that we're using. And now this hopefully should feel comfortable to you. This is what we've been doing all chapter. I'm going to do elimination. You could do substitution. Why wouldn't it be hard to solve for here? But I'm going to do elimination. And would you choose to make your x's the same or make your y's the same? Definitely I would choose my y's, and I'm just going to multiply that by 5. And again, it's because I like to add, and I want to make it the opposite sign of positive 5y. So I have 9x plus 5y equals 12, and 20x minus 5y equals negative 70. And I'm adding, so that's 29x equals negative 58. And when I divide by 29, I get x equals negative 2. And just like we've always done, if I know what x is, can I go back into those 2 equations and solve for y as well? Yes, so I'm solving these equations so I can find x and y. It does not matter which equation you plug back into. You actually could even plug into the one you multiplied by 5. All of them should give us the same answer. I'm just going to plug into the bottom one here. So I'm going to say 4 times negative 2 minus y equals negative 14. Equal signs keep joining together. I thought it was really cool in the video. I've been doing algebra a very long time, like before you were born. And I really liked in the video that every time he had a negative y, like a negative variable, he would always like add it to the other side to make it positive, and then he would add 14 over here, and then he doesn't have to worry about losing a negative sign. And I was like, huh, Patrick, you're so smart. It's the same thing. You could add 8 and then divide by negative. You get you 6 either way. But I just thought that was kind of interesting, the way he did it. I like to pretend Patrick and I are friends. We're really not. I pretend we're on a first name basis. Since I really only know his first name. So, the new part is we have to drop out a letter twice. And we're still not done. If you look at the next slide here, I'm going to double page this. Step 3 is have to go back and find that third variable. Right now we just have x and y, and sometimes you might solve for z and y or z and x, but there's still that one letter, and that's where you have to go all the way back to the beginning. We have 3 equations up here that all have z in it. It does not matter which one you pick, but if you plug x and y into those equations and solve for z, you should all get the same answer no matter which one you pick, if you did this correctly. I'm going to pick the middle one just because it only has a minus z in front of it, but it really doesn't matter. So I'm going to get 2 times negative 2 plus 6, because y is 6, 6, 6, 2 times negative 2 plus 6, minus z equals 5. So that would be negative 4 plus 6, which is 2. And again, using Patrick, my buddy's new way of doing this, I'm going to subtract 5 that way and say z equals negative 3. It's totally okay, just like with 2 equations, you could just circle your answers. Like you could just go through and say x equals negative 2, y equals 6, z equals negative 3, or you could write them as that ordered triple in alphabetical order, negative 2, 6, negative 3. Angelina. In the bottom equation?
Yeah.
So if I plug in negative 2 into the bottom equation, I would get negative 2 plus 24 plus 2z equals 16, right? So that would be 22 plus 2z equals 16. So when I subtract 22, wouldn't that give me a negative?
Yeah, I did 12 instead.
That would give me negative 6, so z would still equal negative 6. It should work. Again, what's frustrating is especially if you know that the answer shouldn't be like that first one that was 40 or whatever, I don't know what it was now. Something over 41. Right, you shouldn't get an answer like that because I'm not going to be that terrible of a person to give you a question like that. And if you get to the end and you get an awful fraction, you know you've messed up somewhere and it's really frustrating and you want to just erase it all, crumple your paper up and throw it at me. You got to not erase, right? Like you got to go back and try to find your mistake. Or if you're on a test and you can't find the mistake, it's better to leave that crazy answer and I can go through and see where you messed up and give you partial credit. Because if you erase it all, I can't give you any credit. So just don't try not to get super frustrated and just like scribble it all out. Angelina does that a lot.
Yeah. And then I lose bonus.
How you feel about that? That's pretty exciting stuff, right? Just know, no solution and all real numbers can happen on this. We kind of talked about that yesterday. So if you see a problem and like you get 0 equals 0, everything cancels out. 0 equals 0, that means infinitely many solutions. If all your letters cancel out, but your numbers don't, and you get like 0 equals 5, that means no solution. So that can happen. It's honestly really nice when it happens because you don't have to do all this work, right? So just know that that can happen. I had another problem on here, but I want to give you time to work, so I want to skip that problem and go to the story problem. Someone asked yesterday, it wasn't someone in here, but someone said, what would these look like in story problem form? And I was like, great question. We'll do that tomorrow. Somebody want to ask? It was already on your paper. Like, don't worry, that question didn't make me do it. But I was like, good question. We'll do that tomorrow. So honestly, I think these story problems are way better than the linear programming problems because those with the constraints, I just really have to think about them sometimes. These are very much like those story problems that we put on the chalkboard last week, except for there's 3 equations and there's 3 unknowns. But the same idea. There's going to be a total amount. There's going to be amount like each chair costs so much, or each thing is worth so much, but then there's just going to be a third one. So it says, a friend emails you the results of a recent high school swim meet. The email states that 24 individuals placed, earning a combined total of 53 points. First place earned 3 points, second place earns 2 points, and third place earned 1 point. There were as many first place finishers as second and third place finishers combined. Write a system of 3 equations that represents how many people finished in each place. Step 1, in any story problem, are what are my variables that I'm trying to find? What are the things I'm trying to find? There should be 3. First place, second place, third place. How many people finished in each place? So I'm going to say I'm gonna change colors here. F equals the number of first place finishers. I'm gonna use a cursive S for the number of second place finishers, and I'm gonna use a T for the number of third place finishers. Again, feel free to use X, Y, and Z if you want, A, B, and C, whatever you want. It just helps me to keep track of it if I use letters that go with it. And then just like our other story problems, we should be able to go through here and write some equations. They tell us that 24 people placed first, second, or third. So all the first place finishers plus all the second place finishers plus all the third place finishers has to equal 24. Yes? What equation would that be? F plus S plus T has to equal 24. Just like the total number of tickets sold or the total number of chairs sold. And then the other one has to do with points, or how much each chair costs or how much each ticket costs. The other one has to do with 53 points. So I know my second equation is going to be equal to 53. But it's not going to just be F plus S plus T, because how much are each one of those points worth, or places worth?
First is 3.
So we would say 3F plus 2S plus 1T, right? So the points have to go with the points. So you got to make sure that you put that together. And that's just like the story problem we did last week. But we have to have a third equation, so that's that last sentence. They tell us there were as many first place finishers as second and third place finishers combined. So they're relating them to each other. So can anybody tell me how we could write that last sentence into an equation? There were as many first place finishers, so I'll start it for you. F equals the first place finishers equals the second and third place finishers combined. You're right. I'm just sounding it out. Don't be so, you always lack confidence in your answers. So now you have to solve it. Story problems. You always have the option, right? We can't have a half a person. So you always have the option that you could guess and check, but you have to make sure that it works for all the equations. You can't just pick 3 numbers that add up to 24. I mean, maybe you get lucky and you get it right, but it has to work in all 3 of those. So guess and check is one option. One option is you could do substitution. This is already kind of set up where F equals S plus T. So you could go through and replace both of those F's with S plus T, and then you'd have all just S's and T's, and you could solve it that way. The third option is you could do elimination, but if you're going to do elimination, you probably want to make it line up. So just think about if you were going to do elimination, you could subtract S, you could subtract T, and this equation would look like this, right? Like this is the same equation, only just set equal to 0. So I love the elimination way. Like I almost always do elimination unless it's like number 1 where I had to do substitution. That's what I would do. So why don't you take a minute and at least try to do the first step. Like I'm going to write this underneath here. F minus S minus T equals 0. Take a minute and think about if you're going to do this like the last example, which letter looks the easiest for you to solve? Does it look easier to get rid of F or S or T? And think about, could I take 2 equations and drop one out and then go back? So let's see if you can do this one before I give you something to do. That's homework. My hands looking at you, right? It's okay.
I know, I remember your own stuff.
It's someone in my last hour that just takes those notes and she gets her notebook out every day and writes in her notebook. And then she uses that, just uses it. Lenny, which letter would you drop out? If you were going to solve that, which letter looks the easiest to solve? T definitely looks. So step 1, if you're going to drop T out, pick 2 equations, just 2 at a time, and try to make T go away. start differently than me, and so don't freak out as I start doing that on the board, because yours could still be right. Unless you do fraction, it shouldn't be a fraction of root. That's not right. Oh, wait.
I can do substitution for the first equation and the second equation. I know it all. So I get both.
Good outlook.
Okay. Yeah. I can look for one.
24. So there's not a lot of variables, like that's what makes it not so bad. So I'm gonna start with the first and the last one. Again, it's okay if you started with like the middle two. But the only reason I picked these two is because the t's are already opposite signs. So when I add these, I get 2f. Oh my gosh, oh, that's amazing. The s's also cancel out. That's always a good day. And I get 24. So I think I get that f equals 12. So sometimes it's kind of weird when you solve the first one and you get an answer, because you're like, what do I do now? Because if you go back and plug just f in, like you still have two unknowns, so you still have to do a little bit of work. So you have some options here. One option is I could just go back and do another one and eliminate t again, and then I could plug it in. Another option is if f equals 12, I could just go back and plug f in as 12 in two equations and solve it that way. So did anybody do that first? The same as me again? So what did you do after that?
Oh, I just got that.
Because then you're like, what do I do, right? Trying to decide what's better to do here. I feel like it's almost just as easy to just go ahead and eliminate t again. So like I'm gonna just kind of pretend that this didn't work out so magically, just because the t's are gonna cross out so nicely here. I have to go back and use this equation that I haven't used yet, right? I have to do that, so I have to use 3f plus 2s plus t equals 53. It doesn't matter whether you use it with the top equation or the bottom equation. You're going to have to use one equation twice every time you do this. Again, I'm going to go with the bottom one because I like adding better than subtracting, so I like picking the one that has the opposite sign. So I'm going to do f minus s minus t equals 0. And if I add these, I get 4f plus s equals 53. And that's what we did last hour too. We did this one first and then we did that one. So it wasn't as stressful to think about what to do. So normally what happens if it was not one where two letters drop out, normally you have two equations with both f and s and you have to go back and do elimination again. But since f equals 12 already, can I just go ahead and plug that in and solve for s right away? And so this one is a little bit easier than the previous one that we did. So I would get 4 times 12, which is 48. 5, is that right? So I know the first place finishers are 12. I know the second place finishers, there were 5. So then I got to go back and plug into the third place. And again, you can plug into any one that you want. In a story problem, I always use the one that's the total amount because it's just easiest for me. I know there were 24 altogether. So honestly, I usually just do that in my head. I just say 24 minus 12 minus 5, but I'll show my work. And I think we end up with 7 third place finishers. I know that it's a lot of work and I know that it's a little bit confusing, but every time it's kind of the same step of go from 3 letters to 2 letters and then go from 2 letters to 1 letter, and then back substitute from there. So I have some problems for you to do. And just kind of looking at these, number one is just like our first example, where there's only 2 letters in each equation, but they're all different 2 letters, so you have to do some substitution on that. And then number 2 and number 3 are like the middle one that we did, and then there's a story problem, but instead of talking about swimming, it's talking about football. So you have like 20 minutes here that you should be able to get a couple of these done at least. If you get stuck, please ask me. Feel free to talk to someone. I'd prefer you at least try it by yourself first. But if it helps to kind of talk with someone, you can. The hard part is trying it by yourself, and you compare to someone else that might have started completely differently than you. But again, try to keep track of your work. If you write really big, you might want to use some of the back side. Like maybe you could use the front side for number 1, and then you could do number 2 on the back, and then you could do number 3 there. Like just have some space there. But the back side is like for you to do that. This is the last thing on our test. Tomorrow we're going to talk about this. Probably I'm going to give you a homework quiz with 1 question like this. We'll see. And then we're going to start reviewing tomorrow and Monday. Hopefully test on Tuesday next week. Please let me know if you get stuck or you have a question. I would be happy to answer it. Oh, child, how do you never know how to do this? What? So it's a green thing. Oh, I'm still recording.